Okay, so screencast number 2, we're going to be disturbing this equilibrium. So what we're going to do is we're going to put stresses on it so that we maximize product. I'm going to show you about minimizing the product, all that kind of stuff. The key that I'm going to use is I'm going to use that or that, anything circled to indicate a stress. Okay, so let's start with purple. So a stress would be to add more purple. So say we had a pipe here, we're going to be adding more purple. So there we go, we're going to add 2 more purples. Okay, so my stress is that I'm increasing the amount of purples. Okay, the system is like, oh my gosh, I can't stand this. I need to be in equilibrium. I need to get rid of the purples. Okay, the question is, how would it get rid of the purples? The only way to get rid of the purples, you guys, is that what we're going to say is it's going to shift to the forward reaction. Those purples are going to combine with a blue to make more product. Blue, blue, erase 2 blues. Okay, so what's going on is the system is like, I'm trying to get back to the same ratio as I was before. That's what I need in order to be in equilibrium. So when we write it down here with the equation, the stress is adding purple. So when you add a stress, the system will shift away from an increase in stress. Just like if you're stressed out by schoolwork, you're not like, oh, give me more schoolwork, I want to be more stressed out. Same thing with chemical equilibrium. If you add stress, the system is going to shift away from it. So the arrow here is going to point away. So see that shift? This is the stress. This is the arrow pointing away from the increased stress. Okay, the other thing you need to know is because our stress was purple, and the only way to get rid of the purple was to make more products, our products in this case would increase. Because adding more purple collides with the blue, turning it into PBB2, notice our blue went down. So that is an example of what can happen. So of course, I don't expect you to be an expert yet. So I'm going to show you some more here. Let me just go back to where we were. I think we had 4. Sorry, I don't quite recall where we were, but something like that. Okay, so let's do another stress. Let's add blue. So let's add blue. So I am going to add blue. That is going to be my stress. So I'm just going to put some more blue in here. And again, the system's like, oh, too many blues, I got to get rid of it. So the system is going to be like, okay, the only way for me to relieve my stress and get rid of that is for those blues to turn into products with a purple. So now I have to erase these over here. Okay, so now the system that is alleviated, the stress is alleviated. Again, here is a stress increase. Just like we would go away from that, it's going to point away from that. It's going to turn into the product, so the concentration of the product is going to increase. Because purple and blue have to collide to make the product, the concentration of purple is going to decrease. Now eventually the blue is also going to decrease, right? But we don't really talk about that. We talk about the stress, the shift, and what happens to everything else. Okay, so let me try to, I completely forgot my original amount, but let's just go here with that. All right, so let's do a couple more here. So say, for example, I take away blue. Like, I'm going to take away blue. So I have a valve, and I'm going to take away blue. So say I take away, I don't know, 2 blue. So the system's like, oh no, I don't want this. It's too ugly. I can't get rid of my blues, right? I need to make more blues. So what's going to happen is the product is going to decompose. And the only way to decompose is for it to turn into 1 purple and 2 blues, because that's what the product is. So what we say is because you're taking away blue, the system is going to shift towards it, or the reverse reaction, to try to make more blue. The only way to make more blue is for it to come from PB2. So the concentration of this is going to go down. The concentration of blue is eventually going to go up, but again, we ignore that. And then the concentration of P is also going to increase by trying to make more blue. Okay, so let me just get back to where I was here. I don't want to get too crazy. think it was something like that. All right, so let's do another one, and I'm not going to draw the pictures above. I'm just going to talk about this here. Okay, so say I'm going to increase my PB B2. So that's my stress. I'm going to throw in a whole bunch of products over here. The system is like, too many products, too many products. Those guys need to break down. And so therefore, as a result, your purple is going to increase and your blue is going to increase. Okay. One more. Let's say I'm going to decrease. My stress is going to be decreasing my product. So the system's like, I want to make more product. I need to have a certain ratio, right? So what it's going to do is it's what we say shift right or favor the forward reaction to make more PBB2. In order to make more PBB2, these two guys, the reactants, have to collide to make that. So both of those concentrations will go down. Okay, so again, you have a couple days for this to sink in, and I have one more thing that I'm going to talk about tomorrow. Same idea, but just a different stress with temperature and pressure and so forth. And then there's a Google Meet tomorrow at 2 p.m.